What is up, everybody? Welcome to partial fractions. Today we are going to not do partial. Today we are going to do partial fractions, but the purpose of this video is not to show you how to do partial fractions. It is to show you how to do partial fractions, but there's a shortcut, right? So normally when you want to do these partial fraction questions, right? This is 5x minus 2 over 2x, right? You have equals. I assume that you already know what partial fractions is. It's a decomposition of fractions into two or more fractions, basically. So this has terms of x plus 4 and x minus 2 if you factor this, right? There you go. Okay, and then you have a plus b. Normally you would just do, well, you would multiply this and this. They all have equal, they all have the greatest common denominator of this. So we can just multiply this whole thing by x squared plus 2 and then erase that, right? And then we can do 5x minus 2 is equal to, well, we have a times x plus 4 already, and then this is x plus 4 and x minus 2. So the x plus 4 cross on these, leaving the x minus 2. So we have a times x minus 2. And then the x minus 2 cross on these, and we have x plus 4. And then we have b plus x plus 4. B times x plus 4. Right? And then we can expand everything. Eventually we'll get a is equal to a plus bx, and then minus 2a plus 4b. So minus 2a, and then we have plus 4b. So we're just gonna do minus 2a plus 4b, right? So the x's add together to the 5. A plus b equals 5, and then minus 2a plus 4b is equal to the minus 2. So we can just double this function, double the top function right here. We'll have 2a plus 2b is equal to 10 minus 2a plus 4b is equal to minus 2. This is the normal way of doing it. I'm doing it the long way. And then we add them together. We'll have 6b is equal to I hope I didn't do this the mathematics wrong. Okay, yeah, I didn't do the mathematics. Did I do the math wrong? I don't think I did. Anyway, 6b is equal to 10 minus 2, which is 8. I might have done the math wrong. If you can fix my math, because this isn't actually supposed to happen. B was supposed to be equal to 2. But this is 8 over 6, which is 4 over 3. And then we can put the 4 over 3 into this equation to solve for a, and a would just be equal to 11 over 3. So this would be the answer, right? You know, this function that isn't actually that good. Let me come up with another one. Let's say we have, oh god, okay, this is not good. Let's say we have we're gonna do a really nice. Wait, should I do a really? Yeah, I'm gonna do a really nice. So 4 over x squared minus 1. Right? So we have this. Now we can still split it into our constituents a and b. So a over x plus 1 plus b over x minus 1, because x squared minus 1, x plus 1, x minus 1. Right? But this is what we can do. We know that for all x, this equation is true. True for all x. True for all x. Except x equals 1 and minus 1. Right? So this is what I'm going to do. I'm going to isolate b. I'm going to multiply by x minus 1. Right? This whole equation is true for all x except x plus 1, x minus 1. So we're going to multiply x minus 1 on all sides. So this will give you now 4 over x plus 1 is equal to a times x plus 1 over x minus 1. A times x minus 1 over x plus 1, I mean. So a times x minus 1 over x plus 1 plus b. Now all of a sudden, minus 1, all of a sudden 1 is not restricted anymore. We can put 1 into the equation now. So yeah, we'll do that. We'll put 1 into the equation. So now if x equals 1, this thing's gone, right? This thing's just gone, right? If x equals 1, I'm gonna put this in color because if x equals 1, this thing's just gone, and this thing's left, right? We'll have 4 over 1 plus 1 equals b, and then b equals 2. And there you go. You got b automatically. It's as simple as that. And then you could solve for a, or you could do it all over again. You could do 4 over x squared minus 1 is equal. This time we have a, so we'll have 4 over x minus 1 is equal to a plus b times x plus 1 over x minus 1. I did the same thing, but instead of x minus 1 is x plus 1, it's x plus 1, x minus 1. And then we can set if x is equal to, let me use a different color. If x is equal to minus 1, then this is gone because minus 1 plus 1 is 0. 0 times b is 0. There's nothing there. And you get 4 over minus 1 is equal to a equal negative 2. So your final partial fractions decomposition from this pretty simple method is minus 2 over x plus 1 plus 2 over x minus 1. Or 2 over x minus 1 minus 2 over x plus 1. And that's it. That's the whole thing, ordeal. Right? You don't need to solve equations, you don't need to do any of that. I did over that really quickly because if I did it slowly it would have taken 10 minutes. But this is the equation. This is called the cover up method, and I'll tell you why. We'll do the next question. I'll tell you why it's called the cover up method. So, oh no, not this one. This one's for linear fractions. 3x minus 4, 2x plus 2. So whenever I see this 2x plus 2 right here, I just factor out the 2. So we'll have 2 times x plus 1. So it'll be 1/2 times 3x minus 4 over x plus 1, x minus 1, which is x squared minus 1, which this is just equal to 1/2 times a over x plus 1, b over x minus 1. Right, the 1/2 we don't have to care about yet. We don't have to care about the 1/2. So we have this function right here, this function, and then we have this function. So we don't have to care about the 1/2. Right? This is why it's called the cover-up method. So whenever we multiply by x minus 1, so let's multiply by x minus 1, right? I'm gonna put it in blue. X minus 1. This is the multiplication. Since we know that when we put 1 in there, it just crosses, it just deletes the other function. It deletes the one that isn't that doesn't have the denominators crossed by the x minus 1. This will be b plus whatever this is. We don't want to know what this is. This is covered up. Is equal to, because it's 0, right? This is equal to 0. If it's equal to 0 if x equals minus 1. So this is covered up, equal to 3x minus 4 over, we have x minus 1 is gone, so x plus 1. So we just put x minus 1 in there. We just put, no, I mean this is 0 if x is equal, this is 0 if x is equal to positive 1. There you go. So we put 1 in there, and then we get b is equal to negative 1/2. right? This is called the cover-up method, right? So you can just put your hand over the a like it doesn't exist, right? So if you're really proficient at this, you can be like, okay, b x plus 1. So a remains and then b is gone, right? So a remains, b gone, and then you can do 3 times minus 1 minus 3 times minus 1 minus 4. If you're really fast at this, you can just do 3 times minus 1 minus 4 over, and then minus 1, which is equal to 7 over 2. 7 over 2. So b is equal to 7 over 2. And then, no, I mean a is equal to 7. A is equal to 7 over 2. So then your final equation will be 7 over 2 x plus 1 plus 1/2 or minus 1/2 x minus 1. So you can put the 2 at the bottom, obviously, but I put it like this because it's useful for when you get into calculus, you want to integrate. It's useful if you put it like this, but you can put the 2 at the bottom. That's totally fair. So what about repeated linear factors? We have x minus 1 to the third power now. And if you have x minus 1 to the third power like this, you have to put it in terms of, first of all, at a factor of x minus 1, then as a factor of x minus 1 squared, and as a factor of x minus 1 to the third power, like this. So we want to use the cover-up method on this. A, B, and C. How do we use the cover-up method on this? Well, if you look here right now, if you take x minus 1, if you just take x minus 1 right here, right, to all of the fractions, if you multiply x minus 1 to everything, this will be gone, and this won't, and this won't. So it's useless. Basically, it's basically useless, right? It doesn't do anything for you, so it's useless. If you put x minus 1, there will still be an x minus 1 factor, x minus 1 squared factor. You can put 1 in, you'll get 0, and then the whole problem's done. So you actually have to multiply everything by the highest x minus 1 power. In this case, it's this one. This time, instead of covering up one thing, you can cover up this whole thing right here. Because whenever you put x equals 1, covered up, right? Equal plus c equal to x squared minus 2. Whenever you put x equals 1, you will have c is equal to minus 1. There you go. That's how you cover it up, right? And then you have minus 1 already, so you actually, this is a little bit hard because you actually have to rewrite the damn equation. You have to rewrite the equation. I'm gonna rewrite the equation right now. So then we'll have this. Actually, I'll keep it there, but I'll make it smaller. So we'll have x squared. No, we'll have x squared minus 2 over x minus 1 to the third power. And then we have, this is minus 1 over x minus 1 cubed now, because we established that c is equal to minus 1. So we can put c over here, turn this minus into a plus. We'll have plus 1 over x minus 1 cubed is equal to a plus b, right? A over x minus 1 plus b over x minus 1 squared. So this minus 2 and plus 1 can combine. They have the same denominator. They're amazing. We'll have x squared minus 1 over x minus 1 to the third power. And what's so nice about this? Well, first of all, if you know the algebraic, if you know algebra, you'll be able to deduce what will happen from this. But let's say we don't know algebra and we want to keep going. We can put x minus 1 squared. Actually, no, we actually can't put x minus 1 squared. We actually have to do the, we actually have to simplify it. So x squared minus 1 is x plus 1 and x minus 1. Right, and then you put this all under x minus 1 to the third power. This will get removed. You have x plus 1 over x minus 1 squared is equal to this a and b, right? So this is now equal to this. Now you take the second highest factor, we do x minus 1 squared, x minus 1 squared, cover this up, I mean, so this is b, so then we'll have b is equal to 1 plus 1, because the x plus 1 is left, and then we have b is equal to 2. Now we do the same thing again, but this time we have b is equal to 2, so what's our equation? Our equation was x plus 1 over x minus 1 squared is equal to a over x minus 1 plus b over x minus 1 plus 2 over x minus 1 squared. So then we put x minus 2, we put 2 over x minus 1 squared on the other side. We'll have x plus 1 minus 2 over x minus 1 squared is equal to a over x minus 1. Lo and behold, we have x minus 1 over x minus 1 squared is equal to a over x minus 1. Cross multiply, do anything you want. I'll simplify. You'll have 1 over x minus 1 is equal to a over x minus 1. So a is equal to 1. And that is how you work out the partial fractions. For repeated linear patterns, quadratics get a lot tougher, and I will will tell you that quadratics get a lot tougher, but I don't know if I might make a second part later, but this is for now. I'm just going to leave it at this. So thanks for watching. The cover-up method is really good. I'm just gonna put a general overview of the cover-up method. So basically, if we have yada 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 over x minus p and x minus q. So basically, if we have f of x, right? Let's put f of x. F of x over x minus p, x minus q is equal to a over x minus p plus b over x minus q, and then continue if you want to. You cover up everything else. If there are different factors, you cover up everything else. So if it's like x minus p, x minus q, x minus r, x minus s, you only want the x minus r. You cover up x minus p, x minus q, and x minus s. So you'll have step 1, multiply x minus p, and then cover b. Step 2, evaluate f of p, f of p over x minus q when, I'm sorry, evaluate f of p over p minus q. Third, multiply by, start again, multiply by x minus q and cover a. I should have put these in capitals. And then fourth, evaluate f of q over q minus p. And then fifth, enjoy. Thanks for watching. I'll see you next time for pre-calculus chapter 3 review.